students. In this lesson, we are going to continue our topic on chemical bonding, and today we will officially go into talking about covalent bonding. Okay, so let's start. All right, so as a recap, let's really just zoom out and look at um, chemical bonding as a bigger picture. Okay, so this topic, chapter 6, we are looking at chemical bonding. All right, and so far we should already know that there are two types of chemical bonding. First type will be ionic bonding, which we have spent a significant amount of time talking about for quite a while now, ionic bonding. So by now we should all be very confident with ionic bonding. If you are still confused, you really need to go and revise. Okay, so then the other one, which we will talk about today, will be covalent bonding. Now, ionic bonding, okay, the way to remember it will be that it is formed between metals and non-metals, right? So if you look at your periodic table, your metals will be the ones that are on the left side, and then non-metals are the one that is on the right side, right, of the staircase. So we always look back at uh, the common examples that we always talk about in class. So for the case of metals, we look at sodium. Okay, so sodium being 2.8.1, it will lose that one valence electron. Whereas for chlorine, which is a non-metal, it will gain the one electron from sodium. Okay, such that, what's the motivation again? Because they want to form the stable octet electronic configuration, right? So when the atom loses or gains electrons in order to form the ion is very stable because it already has the octet, which is 8. Okay, so then when we balance the charges, then that's how we get the formula for the ionic compound, in this case, sodium chloride, NaCl. Okay, so just a quick summary. Basically, ionic bonding, when we talk about in terms of electrons, it is actually the transfer of electrons, right? I lose, you gain. So basically, it's a transfer. Okay, so that is ionic bonding in a nutshell. Now, let's move on to covalent bonding. Okay, so covalent bonding, what is the difference, right? So let's just do like a side-by-side comparison kind of thing. Ionic bonding is metals and non-metals. Covalent bonding, on the other hand, is between non-metals. Okay, non-metals. And again, in terms of electrons, okay, covalent bonding, it is the sharing of electrons. All right. Now, let me give you an example. Okay, so let me change the color. Okay, so if you were to look at the periodic table, right, we look at, let's say, hydrogen. Okay, now hydrogen is very special in the sense that it is sitting right smack in the middle of the periodic table. So some students might sometimes wonder, oh, wow, don't know whether hydrogen is metal or not metal. Okay, so you just need to use your common sense, right? You think about it. Hydrogen is a gas that's present in air. Surely it cannot be a metal lah, right? Hydrogen is a non-metal. Okay, so and as we know from our previous chapters, hydrogen exists as H2, right? At room temperature and pressure. So if we were to look at the bonding within a H2 molecule, okay, this is how it goes. Okay, follow through with me the train of thought. So now we have one hydrogen and another hydrogen atom. Okay, both of them are non-metals, right? So now they are still atoms. Okay, so they have not undergone bonding yet. Okay, so let's try to rationalize how chemical bonding is going to be like for hydrogen and another hydrogen. Okay, all right. So this is the starting point, right? So this part that I'm circling here, this is the starting point. Okay, we are trying to move from our understanding of atoms into molecules now. Okay, okay. So over here, I'm going to demonstrate to you to show you that ionic bonding cannot happen to hydrogen. Okay, so for instance, in order to become stable, in this case, hydrogen wants to be the stable duplet, right? Duplet meaning 2. So assuming this first hydrogen gives donates the electron to this second hydrogen, okay, then what will happen? You tell me what will happen. The first hydrogen, it will end up with no electrons, right? The valence shell is totally empty. Whereas the second hydrogen, okay lah, it achieves the stable duplet. Okay, so in this case, that's why I say ionic bonding cannot happen, because one of your hydrogen can become stable, but the other one is super unstable, right? There's no electrons at all. Okay, then you'll be wondering, ionic bonding cannot, then how? So that's where covalent bonding comes in. Okay, and I'll just cut straight to the point. What will happen is that they will share their electrons, right? Share. I share you, you share me, so that we can so-called double count it, whatever that is being shared. Okay, so now if we look at the first hydrogen, okay, it has achieved a stable duplet, because now in its valence shell, it has 2 electrons. Likewise, for the other hydrogen, it also has 2 electrons. So both are stable. So this is your covalent molecule, okay, H2. Okay, so to help you bridge this gap, right, between the difference between ionic and covalent, let me give you an analogy, okay? So for instance, you imagine that, let's say you play sports and then you broke your arm, right? Let's say you are right-hander, you broke your right arm, then you cannot do any writing, correct? So what happens is that there can be a few scenarios, okay? So let's say you have a very good friend, your best friend, okay, decides that, okay, case number 1, what your friend can do is that, okay, your friend will share his arm with you, right? What does that mean? So maybe it means he helped you uh, to do writing and so on and so forth. Okay, he shares that arm with you so that he can do his own homework, yet at the same time he can help you as well. Okay. Another case is a bit extreme. What happens is that your friend maybe can chop off his arm and give his arm to you totally, right? I know it really sounds very strange, but this will really help you remember the difference between ionic and covalent. Okay, so number 2 doesn't happen at all, right? I mean, it really just sounds ridiculous. Okay, so this analogy basically is just me trying to help you remember, okay? To illustrate that, case number 1 is covalent. If you share the electrons. Sharing of electrons is always covalent bonding, whereas case number 2, right, the so-called chopping off of the arms it represents transfer of electrons. Okay, so in the case of covalent, you cannot transfer electrons. Okay, it is a share. Okay, yeah. So if you look at your notes, right, you turn to the summary notes first page. Okay, you see this, right? This is the flow chart that I've done for you. Okay, so again, same thing. Chemical bonding, there's 2 types, ionic and covalent. So ionic, it is when your atoms gain or lose electrons to attain the stable duplet or octet electronic configuration, right? And again, the ones that will lose electrons are your metals, your metallic atoms, and then your non-metallic atoms are the ones that will gain the electrons. Okay, so if you just look at this little diagram here, you can also think of it as, opposites will attract, right? So yeah, your cations will attract the anions, and then once the charges are balanced, you form your ionic compound. Okay, they complete each other. Covalent bonding, on the other hand, is when atoms share electrons, again, to attain stable octet or duplet electronic configuration. Okay, so share. I share you, you share me, so we can so-called double count the electrons that are being shared. Okay, yeah, so over here, I just want you to take note that, okay, when we say that there's a covalent bond, that a pair of electrons are being shared, meaning there's 2. Okay, so later on when we look at specific examples, it will become a lot clearer to you. But right now, I just want you to jot this down at the side. Okay, so if you see a single line, right, representing a single covalent bond, that means that 2 electrons are shared. Okay, then later on we will see some examples, such as, let's say, oxygen gas, O2. It is a double covalent bond, so there are 4 electrons that are shared. And then finally, triple covalent bond for nitrogen molecule, for instance, it is 6 electrons shared. Okay, yeah. And for covalent bonding, again, is between 2 non-metals. Okay, let's move on to the next part. Okay, so let's move to our notes. Okay, all right, so we are going to officially start on covalent bonding. All right, so okay, so covalent bonding, what is it? It is the sharing of electrons. Okay, so covalent bonds, they are formed between atoms of non-metals. Okay, it is done through the sharing of your valence electrons between 2 atoms. Okay, so again, as a gentle reminder, right? Um, the chemical reactions, basically, we are just talking about electrons that are on the outermost shell, right? Because those that are inside, they are not really affected in that sense. Okay, and each atom in the molecule achieves the stable electronic configuration of a noble gas, meaning duplet or octet. Okay. All right, so now let's quickly just refresh our memory on what molecules are about. This one we have seen it in Sec 1, in fact, right? Lower Sec Science. So just a quick recap. Okay, so the first type of molecule will be when covalent bonds are formed between atoms of the same element. Okay, so remember in chapter 4 we talk about elements, right? And you should remember that these special types are called diatomic molecules. So di meaning two. Okay, atomic just means atoms. So molecules that are made up of 2 atoms, just 2. Okay, so like your hydrogen H2, oxygen O2, and so on. Second type will be when your covalent bonds are formed between atoms of different elements. Okay, so thereby forming compounds. So these are your common examples, right? Water, methane, carbon dioxide, and ammonia. And then this again is a reminder on what is the definition of molecule. Okay, group of 2 or more atoms. Sorry about the disruption. So come back to this. So molecule is formed when a group of 2 or more atoms are held together by covalent bonds. Okay. All right. So now let's cut straight to drawing of dot and cross diagrams of covalent compounds. Okay. So if you were to refer to your notes, right? Again, I have uh, a couple examples for you, similar to that of ionic bonding. Okay, so now we will basically just focus on drawing these diagrams. Okay, so if we look at the first example, hydrogen. Is this video playing? Okay. Yeah. So okay, so again, looking at the atom itself, hydrogen electronic configuration is 1. Okay, so hydrogen is special. It is just one element before helium. So in this case, hydrogen would want to form the duplet electronic configuration. So what can it do? It needs one more, right? Okay, so the trick is this. For covalent bonding, you can think of it as, let's say for hydrogen, it needs one more, right? So what hydrogen will do is it will contribute 1 electron for sharing. Okay, so for instance, again, let's draw the atom. So we write the chemical symbol, then we draw the electron shell. Okay, then what I find useful is immediately you just draw the shell overlapping. Okay, then you put in the electrons. Okay, so cross representing electron from the first hydrogen, dot representing the electron for the second hydrogen. Okay, so contribute 1 each, and then because you can double count, so each hydrogen is a duplet, a stable duplet. Okay, so simple, that's 2 marks. Okay, so let's have a look at chlorine. All right, so Cl2. So you know that each chlorine atom electronic configuration is 2.8.7. All right, and in this question, I just want to remind you again that if the question never say that you should only show valence electrons, you need to draw all electron shells. Okay, so okay, Cl, your first shell has 2 electrons. Second shell has 8. It is fully filled. So you should draw 1, 2, 3, 4, 5, 6, 7, 8 electrons. And now, because I'm using iPad, so I'm just going to be a little lazy. I will copy and paste for my drawing of the other atom. Okay, but of course, over here, very importantly, I will definitely have to change the symbol. Okay, but before that, as you can see, I'm drawing the third shell in, and be very conscious that you need to overlap the shells, okay, because sharing of electrons is happening. Okay, so I am trying to erase all these crosses, okay, and change it to the dot symbol instead. Okay, because why? Again, we are looking at dot and cross diagrams, right? Not dot dot diagram, not cross cross diagram. So be very careful about that. Okay, so I fill in the first two electron shells, 2.8. And then now let's look at the valence shell. So each chlorine should have 7, right? So 1, 2, 3, 4, 5, 6, 7. Because like I said, because chlorine needs one more, so it will contribute 1 to sharing. Likewise, the other chlorine contributes 1. Okay, so that's how you get this one single covalent bond. Okay, so I'm going to write for you single covalent bond. So each covalent bond, let me write it at the side. Right, a covalent bond, basically what it means is that it is the sharing of a pair of electrons. Pair means two, right? A pair of shoes, a pair of glasses. So pair means two. Okay, 1, 2. 2 electrons. So yeah, that's for chlorine. 2 marks. Okay? Okay, so let's carry on with example number 3, which is oxygen gas, O2. Okay, so as mentioned, as the examples carry on, right, it just gets more and more tricky, more things to take note of. But the steps should remain the same. Okay, so oxygen atom, the electronic configuration is 2.6. Alright, so again, using the trick that I taught you, right, knowing that it is 2.6, oxygen needs 2 more electrons to form the octet. Okay, so it will in turn contribute 2 electrons into the sharing, okay, into the covalent bond. So again, we draw the first shell first, which contains 2 electrons. Then when we draw the second shell, we draw it a bit bigger and ensure that it overlaps like this. Okay, keeping in mind that you need to draw dot and cross. Okay, shift around. Yeah. Then after that, so oxygen needs to contribute 2, right? So you draw that 2 first. Okay, so for instance, for the first oxygen, I will put 2 crosses inside the sharing there, 1 and 2. Okay, then likewise for second oxygen, I put the dots. Okay, and then finally, then I will check, right? Because per oxygen, it has 6 electrons in the outermost shell, right? So 2 has already been contributed to the covalent bond, so you are left with 4. So that's why here 1, 2, 3, 4. Likewise, okay, at this point I need to remind you that electrons, right, they need to be paired up. So you cannot draw like, let's say one electron is here, then the other one is here. Okay, as for this one, right, it's a A-level kind of understanding, so you don't really need to know at this stage. But if you truly want to know, you can always find me, I can explain to you. Okay, so just check that all these are correct, right? Both your oxygen needs to be a stable octet. Okay, then you get the full 2 marks, right? So if you were to, let's say, check the first oxygen, we have 1, 2, 3, 4, 5, 6, 7, 8, right? So 8 electrons, so it's a stable octet, no problem. Likewise, for your second oxygen, okay, the bonding electrons can double count. So again, 1, 2, 3, 4, 5, 6, 7, 8. Stable octet electronic configuration again. Okay, so as long as you have checked all these things, they are correct, then yeah, you will get the full 2 marks for your diagram. Okay, let's move on to example 4, which is nitrogen gas N2. Let me scroll down. Does the video end here? Oh, okay. Oh yeah, let me remind you. So just now I said, there's another form of representation. Okay, so if you write a single bond like this, it represents two electrons being shared. So for instance, for chlorine here, right, single bond. Then for oxygen, oh no, I scroll away already. For oxygen, it's you share two pairs of electrons. That's why it's O, then double bond O. Okay. Okay, then example 4, nitrogen. So nitrogen, the electronic configuration is 2.5. So again, using that trick, right? To get to octet, which is 8, you need 3 electrons. So each nitrogen atom will contribute 3 electrons to the sharing. Okay, so we draw the first shell first because that part is the easiest. So 1, 2, and 1, 2 using the dot and cross symbols respectively. Then the second shell, draw a bit bigger such that you can overlap them. Try to draw it same size, okay, because they are the same atom, they have the same size. Okay, then put in the electrons that are being shared. So 1, 2, 3 and 1, 2, 3. Okay, so if at this point you can understand what I'm trying to say already, right? So that's why I say nitrogen is a triple bond because you share 3 pairs of electrons. 1, 2, 3. Okay, then again, just be very careful. You already have 3 electrons per nitrogen that is shared in the covalent bonding there, the covalent bond. So you are just left with 2 electrons to be filled up outside, so to speak. Okay, so yeah, this is your full 2 marks. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons, you got octet, then you're done. Okay, now let's move on to the more exciting part of the drawing of diagrams. So we will look at examples 5 and beyond. So far, examples 1 to 4 are diatomic molecules, so really quite easy to draw. But so example 5 onwards will get more exciting. Okay, so for water, but the steps remain the same lah. Okay, so looking at the atoms that form up these compounds, it will be hydrogen and oxygen. So hydrogen is 1, then oxygen is 2.6, right? So hydrogen is 1 more to form duplet, so it will contribute 1 into the sharing. And then oxygen, because it needs 2 more to become octet, it will share 2. Okay, so with the understanding and also our prior knowledge that water is H2O and it has the Mickey Mouse shape, right, so to speak, we can actually go ahead and draw oxygen first. Okay, so inner shell, 2 electrons, and then outer shell, right? And this is the part where I'm going to remind you again, you really need to follow the convention that I taught you. Okay, if not, otherwise your oxygen atom you will draw wrongly, and then the final shape of your covalent compound doesn't look like what it should be. Okay, so this is how it looks like, right? I've shown you the molecule in class. This is how it looks like, a little bent shape over here. So yeah, if you fill in the electrons here, second shell has 6, right? 1, 2, 3, 4, 5, 6. And then after that, you draw in the hydrogen, so 1 over here, okay, where it shares 1 electron with your first oxygen electron here, and then the other one will share with the other one. So that's why oxygen contributes 2 in total for the sharing, 1 and 2. Okay, so this is your water diagram, 2 marks. Okay, alright, moving on. Example 6, which is methane. Same thing. Look at carbon and hydrogen. So hydrogen electronic configuration is 1, methane is 2.4. Okay, so if we look at methane, right, 4, meaning it needs 4 more electrons to form octet. Okay, so keeping that in mind, we will need to share 4 electrons in total. Okay, and in fact, if you scrutinize the chemical formula a bit closely, right, you can also figure out that methane looks like this. Okay, to give you a little clue lah. Then okay, so carbon, it will be like this, right? 2.4. And then each of your hydrogen atom, because they need to share one, right? And over here in methane, the chemical formula is H4, CH4. So you need 4 hydrogens. So just nice, it will just share with one of each of the 4 carbon electrons that needs to be shared. So 1, 2, 3, 4, 5, 6, 7, 8 octet around carbon, and then duplet 1, 2 around hydrogen. Okay, so very stable. So this is your methane. Okay, so notice over here, right? This one pair of electrons forms this covalent bond, this pair forms this covalent bond, and so on and so forth. Example 7, carbon dioxide. And like I said, with every example that goes, it's a little more tricky. So carbon dioxide is tricky because there's 2 double covalent bonds. Okay, so again, we have carbon that needs to share 4 electrons in total. Oxygen needs to share 2. Okay, so in a way, I would say this requires a bit of mathematical manipulation. If you are more intuitive with math, that might help you a bit. Okay, but to help you a bit over here, you see that carbon dioxide actually has this structure. Double, 2 of your double covalent bonds. Okay, so yeah. Over here, at this point in time, I'm already very sleepy because it's again in the wee hours of the night. So you will see me trying very hard to shift things around. But basically, I'm trying to draw the diagram for carbon dioxide. Okay, so I will, as usual, draw the inner shells first because it's very straightforward. And then when you draw the outermost shell, make sure that you overlap the electron shells such that there's space for your shared electrons. Okay, so yeah. So once your shells have been drawn, then you can go ahead and put in the electrons. So again, oxygen, right, it needs to share 2. Okay, so it will put in 2, right, 2 dots. Likewise for the other oxygen, 2 dots. Whereas for carbon, because it needs to share 4, right, so you notice over here, the cross symbol, which represents the electron for carbon, there's 4 over here. So 1, 2 on the left, and then 3, 4 on the right. Okay, then final step, we check, right, whether everything is octet. So over here, around the carbon atom, there's 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons, so it's octet. Okay, so this part here is stable. So now we just need to fill in the oxygen part. Okay, so 1, 2, 3, 4, 5, 6. Stable also. Likewise for this oxygen. Okay, if you find that I went too fast, you can always scroll back to the video and watch again. Okay, example 8, ammonia, same thing. Nitrogen is 2.5, it needs to share 3, and then you have hydrogen that needs to share 1. Okay, so again, if you know the chemical formula, it's very easy. So there's 3 hydrogens surrounding your nitrogen, so it should look something like this. Okay, so again, in your diagram, draw the central atom first, which is nitrogen. Okay, so 2.5, right? 1, 2, 3, 4, 5. Okay, then you see this lone electron, right? So that's not good. So that's where your hydrogen will come and form the covalent bond with that lone electron. Okay, yeah. So again, same thing. This pair of electrons is this bond. I'm highlighting for you. This pair of electrons is this bond. This pair of electrons is this bond. This pair of electrons is this bond. Okay, that's why it's NH3. Okay, so octet around nitrogen, duplet around hydrogen. Very stable. So that is your final answer. Okay. Okay, let's look at the last part of this lesson on covalent bonding, which is on the structure and physical properties of covalent compounds. Okay, so This part will be highly similar to the one on ionic bonding, just that, of course, the details are slightly different. Okay, so in terms of structure, you need to know that most covalent substances, they exist as simple molecules. All right. And now this is the part that will get potentially confusing, but you need to know the difference. So the atoms in the molecules, they are held by strong covalent bonds. Okay, so let me again take this opportunity to remind you of this, right? Back in chapter 1, we said you need to know the difference between the three particles eventually. Okay, and now is the time. By the time we finish this chapter, which is today, now, you need to know the difference between atoms, ions, and molecules. And particles is just a general term to refer to these three. Okay, so basically, please can you put a lot of stars for these two parts, strong covalent bonds and weak intermolecular forces of attraction. You need to understand. So if we look at water, which is H2O, and likewise we can represent in this format in the so-called Mickey Mouse structure. Okay, you see that over here I have two molecules of water here, right? One, two. Okay, so so you see these are in pink. This particular line, this line, as well as this line and this line, all these represent the strong covalent bonds. Okay, so again, what is strong covalent bonds, right? It is the bonds that are holding your atoms, so hydrogen atom, oxygen atom, in this molecule together. Whereas this little line here in purple, this represents the weak intermolecular forces of attraction between the molecules. Okay, so let's have a look at this term, intermolecular. Okay, you can think of it as, let's say, like during sports meets, right? You have inter-class competition. Inter-class means between different classes, right? So in this case, the term intermolecular basically just means between different molecules. Okay, so the weak intermolecular forces of attraction between this water molecule and this water molecule. Okay, so can you please draw a lot of stars for this, because students will always get confused by this. The difference between strong covalent bonds between atoms within the molecule versus weak intermolecular forces of attraction between the molecules. Okay, it's very different. If you are confused, please turn back in time, go back and play the video again. Okay. Moving on, physical properties. Number one, melting and boiling points. So in light of the weak intermolecular forces of attraction between your molecules, your covalent compounds, okay, those with simple molecular structures, they have low melting and boiling points. Okay, for pure chemistry students, you will need to know giant structures as well. So that one is for another time. Okay, now this part over here is really for your explanation, okay, for exam questions. Why do they have low melting and boiling points? Because very little energy is required to overcome these weak intermolecular forces of attraction. All right, so usually they exist as gases or volatile liquids. Secondly, solubility in water. This is complete opposite from ionic compounds. Okay, so covalent compounds, usually they are insoluble in water, but then they are soluble in organic solvents. So such as like your ethanol. And then finally, on electrical conductivity, okay, most substances with simple molecular structures, they do not conduct electricity in any state. Okay, please highlight this as well. Put a big star on this part on any state. Okay, you need this full answer written down for the full mark. Okay, or to explain why covalent substances are unable to conduct electricity. Okay, so be it in the solid state, liquid state, gaseous state, there's no way covalent substances can conduct electricity. Because why? Again, this part will form your explanation. It's because covalent substances do not have free moving ions or electrons in all the states. Okay, and again, for pure chemistry students, you will know that there is an exception, which is carbon in the form of graphite, okay, which I will not cover in this particular video. Okay, so that is it. We have come to the end of covalent bonding and chemical bonding as a whole. So students, if really at this point you are confused, I highly suggest that you watch the relevant parts of this video again. And please reach out to me either through the Padlet or we can do small group consultations. Please reach out to me during this period of home-based learning. If you have doubts, you really have to clarify. Otherwise, when we go back to school, it's going to be a bit too late. Okay, so enjoy your learning and please don't give up. Chemistry is not that simple, but if you can understand and appreciate, it's actually very fun. Okay, just nice 1 a.m. It's time for me to take a rest and go to sleep as well. Okay, goodbye. I'm gonna end the video right here.